Task number 2, main components of Metasploit. This task is part of the Metasploit introduction module, which is part of the complete beginner path on TryHackMe. We also have the task number 1, introduction to Metasploit, which basically goes through what will come next. So that being said, main components of Metasploit. While using the Metasploit framework, you will primarily interact with the Metasploit console. You can launch it from the attack box terminal using the msf console command. The console will be your main interface to interact with the different modules of the Metasploit framework. Modules are small components within the Metasploit framework that are built to perform a specific task, such as exploiting a vulnerability, scanning a target, or performing a brute force attack. Before diving into modules, it would be helpful to clarify a few recurring concepts: vulnerability, exploit, and payload. An exploit is a piece of code that uses a vulnerability present on the target system. This is something very important in security. Exploit is a piece of code that uses a vulnerability present on the target system. Right? The vulnerability is already there. A vulnerability, a design, coding, or logic flaw affecting the target system. The exploitation of a vulnerability can result in disclosing confidential information or allowing the attacker to execute code on the target system. Right? Vulnerability is the flaw. Exploit is basically the exploitation of the flaw. Payload, an exploit will take advantage of a vulnerability. However, if we want the exploit to have the results we want, gaining access to the target system, read confidential information, and so on, we need to use a payload. Payloads are the code that will run on the target system, right? So exploit is basically the code in this context that uses the vulnerability, the flaw, the weakness in a system, in design, in code, or in logic flaw, because basically apps and systems are built by humans. Payload is basically, again, in this context, let's say it's code. It's basically a piece of code that when we use the payload, we basically have a access, right, on the target system. So very simply put, exploitation is basically code that uses a vulnerability in the system. Vulnerability, flaw, weakness. You can think of it, it's the same thing. Payload is the trigger of the exploit in order to, again, have access to data, to the system, to the target, whatever. I hope I explained it well. Modules and categories under each one are listed below. These are given for reference purposes, but you will interact with them through the Metasploit console. Auxiliary. So this is a module. Encoders, another module. Evasion, exploits, NOPs, payloads, and post. And you can see inside each of them, they are divided in more sections. The auxiliary module. Any supporting module such as scanners, crawlers, and fuzzers can be found here. We can see inside the auxiliary module, we can see fuzzers, gathers, parsers, right? Scanners, sniffers, spoofing, clouds, clients, whatever. We can find it over auxiliary module. Encoders will allow you to encode the exploit and payload in the hope that a signature-based antivirus solution may miss them. Signature-based antivirus and security solutions have a database of known threats. They detect threats by comparing suspicious files to this database and raise an alert if there is a match. Thus, encoders can have a limited success rate, as antivirus solutions can perform additional checks. And you can see the extra encoders that we have. Evasion. While encoders will encode the payload, they should not be considered a direct attempt to evade antivirus software. On the other hand, evasion modules will try that with more or less success. You can see them over here. As you can see, we have evasion on Windows. Exploits. Exploits neatly organized by target system. Yes, we can see a lot of target systems. NOPs, no operation. Do nothing, literally. They are represented in the Intel x86. They are represented in the Intel x86 CPU family with 0x90, following which the CPU will do nothing for one cycle. They are often used as a buffer to achieve consistent payload sizes. Can see them over here. Payloads are codes that will run on the target system. Exploits will leverage a vulnerability on the target system, but to achieve the desired result, we will need a payload. Examples could be getting a shell, loading a malware or a backdoor to the target system, running a command, or launching CalcX, the calculator application, as a proof of concept to add to the penetration test report. Starting the calculator on the target system remotely by launching the application is a benign way to show that we can run commands on the target system. Running commands on the target system is already an important step, but having an interactive connection to that that allows you to type commands that will be executed on the target system is better. Such an interactive command line is called a shell. Metasploits offer the ability to send different payloads that can open shells on the target system. We saw that already. We opened up some shells with Metasploit. Here you see the payloads. You will see 4 different directories under payloads: adapters, singles, stagers, and stages. Adapters, an adapter wraps single payloads to convert them into different formats. For example, a normal single payload can be wrapped inside a PowerShell adapter, which will make a single PowerShell command that will execute the payload. Singles, self-contained payloads, add user launch notification, launch notepad, and so on, that do not need to download an additional component to run. Stagers, responsible for setting up a connection channel between Metasploit and the target system, useful when working with staged payloads. Staged payloads will first upload the stager on the target system, then download the rest of the payload, which is the stage. This provides some advantages, as the initial size of the payload will be relatively small compared to the full payload sent at once. Stages downloaded by the stager. This will allow you to use larger size payloads. Metasploit has a subtle way to help you identify single, also called inline payloads, and staged payloads. Generic, we see it over here, generic / shell reverse TCP and Windows x64 shell reverse TCP. Both are reverse Windows shells, the former inline or a single payload, as indicated by the underscore between shell and reverse, while the latter is a staged payload, indicated by the / between the shell and a reverse. Post module will be useful on the final stage of the penetration testing process listed above, post exploitation. And you can see here the contents of post module. If you wish to familiarize yourself further with this module, you can find them under the module folder of your Metasploit installation. For the attack box, these are under here you can see the default location of these Metasploit modules. Answer the questions below. What is the name of the code taking advantage of a flaw on the target system? So this is the exploit. We have the code that takes advantage of a flaw, but it's not triggered yet, right? It's not yet activated. What is the name of the code that runs on the target system to achieve the attacker's goal? This is the payload. What are self-contained payloads called? Here in the payloads modules, you can see singles, self-contained payloads that do not need to download an additional component to run. Singles. Is Windows x64 ping back reverse TCP among singles or staged payloads? Well, We can go over here and you can see both of these between shell and reverse. We can see a forward slash here, and between shell and reverse we can see an underscore here, right? So this one is a single, is an inline or a single payload, this one, but this one is a staged payload. So we have a single singles, right?